What's good, Year 11 VCAL Numeracy class? Mr. Herman here, and this video will be looking at log 8, the median, 36.9. We're attempting all the questions from here. You'll notice that I've made a video for log 6, but I have not created a video for log 7, and the reason why is I still want you to do the questions for log 7, but it is on the same topic, the mean. The only difference is 36.7 shows you the calculator way of working out the mean using the functions on there. I'm not going to bother with that. In fact, I unfortunately don't have the emulator on my computer to show you this. So for now, just answer the questions 1 and 2 like you would normally do to work out the mean, the skill from log 6. And once you've attempted those questions, you can have a watch of the rest of this video for log 8, the median. So the median is another measure of the middle, and median is just that, it's middle. That's what median means in this statistics world. Median just means middle. So there are different ways that we can work out an average, and there are 3 main ways. So averages can be split up into 3 ways. The first one is your mean, and this you've seen in the previous video. You get all your data points and you divide by how many data points there are. The second one is the median, or the middle value, and this is the skill set that we're going to look at now, and it seems like it's pretty easy to find the middle value, and this is true. There are just 2 different circumstances you've got to consider, and we'll look into that in a second. And the third way is the mode. The mode is the most common number, the most popular number within a data set. There is no wrong or right way of working out the averages, or which average you should use rather, when it comes to the data set. But what is important is it depends on what data set you have. It depends on how spread the data set is. If the data set clusters more to a certain number, if the distribution is very close to each other, if there are any outliers or any weird numbers that stand out, it really depends on which method is the best. But for now, we're just going to focus on the skill set of how to work out the median. So the median is the middle score of the distribution, okay? Hence why I wrote middle. And determine when the scores are placed in order of size from smallest to largest. And this factor right here is very important. So for example, the median of the scores here, 11, 3, 2, 7, 6, 5, 8, 7, 4, I'm surprised I did not mess that up, is obtained by first writing them in order. So you have to put them in order from smallest to largest. 2, 3, 4, 5, 6, 7, 7, 8, 11. Nice. And noticing that the middle score in this case is 6. So we look, and a good way to check it, if we're just going to look at this in a very face value way, is you're just going to work forwards and backwards, and you keep doing this until you get to your middle number. So we did this 3 times, so we ended there, 3 times, ended there. Hey, our median is 6. Alright, so our middle number is 6. So another way of saying the average for this data set, the average, if worked out in the form of a median, is 6. So this 6 is the best representation number for all of this data set. Okay, just one of the 3 different ways here. Now, this happens when there are 1, 2, 3, 4, 5, 6, 7, 8, 9, when there's an odd amount of numbers. When there's an odd amount of numbers in the data set, so in this case, this is 9, we know that we can take one middle value. Okay, it's very easy to just be able to take one middle value. But if there are an even amount of numbers, what will happen is there will be 2 middle scores. So let's take this example here, 11, 3, 2, 7, 6, 5, 8, 7, 4, 3. And then we put it in order of 2, 3, 3, 4, 5, 6, 7, 7, 8, 11. We've added an extra 3 in this case. So the amount of values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 values. There'll be 1, 2, 3, 4, 5, on one side and 1, 2, 3, 4, 5 on the other side. And then what ends up happening is that there are no middle values to take from here. There's nothing in there because we've got this even split. So instead what we do is we take the end of the first half and the start of the second half. In other words, the two middle values. So we take the two middle values. Now we don't necessarily say that there are two medians in this case. We work out the average in the form of a mean for this. So we'll take 5 and 6, we add them together and divide it by 2. And this ends up being 5.5. Another way I think of it is I look at 5 and I look at 6 and I say, hey, what's in the middle of 5 and 6? In this case, it's 5.5. If the two middle numbers were, say, 9 and 11, and you say, what's the middle number between 9 and 11? This ends up being 20. Again, you can work it out through this average way. 9 plus 11 is 20, and 20 divided by 2 is 10. Works either way, okay? So it's just like finding the middle number of two values. What we're going to do is we're going to look at this example here, and we'll have a look to see how we find the median for these two different scenarios. We've got to make sure that we order them from smallest to largest. And I want to show you some of the tactics that I use to be able to find the positioning of the median value. And so the positioning just means, hey, what position does it happen depending on how many data sets there are? And there's a cool little formula that I can show you. By all means, you can use it. If it looks a bit too tricky, you can always just count your way in, but it does save quite a bit of time. Let's first look into the first data set. We're going to find the median of A. Now, you'll notice that these numbers are not in order. So we're going to go ahead and put them in order from smallest to largest. Give me 2 seconds, guys. Way to go, software editing magic voodoo. Here is the ordered numbers for example A. The next thing we're going to do is we're going to count how many data values are there within here. This is going to help us determine whether this is going to be one middle number or two middle numbers. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the number of data points I'm just going to represent by the letter N. N is equal to 15. Now, we expect, because it's an odd amount, we expect one number to just extract for our median. But how we know what this position is, you can either do it one of two ways. The first way is just the method that I used before, is just counting in. You can either cross them off and keep going until you have one number left. Or what you can do is you can find the position. You can find the position based on this formula. And the formula goes as this. You take how many values you have. So you take your N value, in this case is 15. I'm just going to write it in general form for now. And then you add 1 to it. Okay, so you take your position, your data points, sorry. You add 1. Then whatever answer you get, you divide this by 2. This will give you the position. And I'm gonna put here TH. TH just means a position. Okay, so I'll just be careful with this. This will find you the nth position for your median. So let's plug in this N value and see what we get. So we know right now our N is equal to 15 plus 1, all of that divided by 2. 15 plus 1 is 16, and 16 divided by 2 is 8. Or in other words, our 8th position is our median number. 1, 2, 3, 4, 5, 6, 7, 8. Now, a lot of students always ask me, if I can just count in, wouldn't that be not necessarily easier, because this makes sense to them, but wouldn't that be quicker instead of writing this all out? And I say to them, look, it really depends on how many data values you have. Because n equals 15 is a relatively small amount, it's pretty simple to just count in. But when you have, say, data values where there's about 400 or 436 or 9,250, and it does happen depending on your surveys, it's really tricky to find that median value by counting in on both ends. But the formula will still remain the same if you use this method, okay? So again, you can use this if you wish. It really depends on what you find easy. I find this easy because I can just go, oh, 8th position, I just got to count in one way as opposed to counting in both ways, okay? And this also works if the amount is even. Okay, so this amount works for odd numbers. It does work for even numbers, but there's a little thing that you have to be careful about. All right, here is this data set. Let's put it from smallest to largest. Software editing, do your thing. Alrighty, we have got our values from smallest to largest. Let's count what our n value is. How many data points do we have in here? Our n value, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We have 18 values, and this is an even number. So we are expecting 2 middle values from an even amount of data points, and then we're going to work out the mean of those 2 values, or the middle section of those 2 values. Now I'm going to use that position formula here again with this. Okay, again, you can count backwards, but we're in year 11 now, so let's try to find efficient ways. Let's try to find efficient mathematical shortcuts to help us. So the position again is n plus 1 over 2. Now it seems like that you run into a bit of a hiccup when we work this out, because we end up getting a decimal number. So n plus 1, 18 plus 1 all over 2, which is 19 divided by 2. 19 divided by 2, that is 9.5. Ooh, what the heck is the 19.5th position? What does that mean? Well, 9.5 is actually just telling you that it is in between the 9th and the 10th value, right? Because 9.5 is in the middle of 9 and 10. Remember, these are just positions. We've just found the smack bang position for the median for this data set. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Our 9.5 is right here, so this is just saying, hey, let's take 4 for the 9th and 4 again for our 10th. So whenever you get a decimal answer for your position, it just means find what it's closest to on both ends, the 9th and 10th, and that will give you your median position. And this is easy because in between 4 and 4 is 4. If the numbers are the same, then the median in this case is 4. So our median is 4. Now, I have to backtrack. Median is 4. Or 4 plus 4 over 2. So it's the average of the two numbers. 4 plus 4 is 8. 8 divided by 2 is 4. So our median in this case is 4. I did not write what my median value was for the other one. Median in this case is equal to 6. There we go. I just wrote what the position was. I didn't write the answer. And so that's all there is to it to finding the median. Remember, you can just count in. Okay, you can count in from the start and count in from the end, not n, end, E-N-D. But I find that this positioning format works really well. Even though we get this decimal number, don't be intimidated by this. This is just saying between the 9th and 10th value. If it was 12.5, it would be the 12th and the 13th value. If it was 97.5, it would be the 97th and the 98th value, and you count in. But I highly doubt you'll be answering questions when there's over 200 data points. For now, use those formulas as is. Remember, your questions that you need to do are for log 8. All of the questions. Till then, I will see you in the next video. Bye bye.